What's up, guys? Let's go. Back at it again. Today we're going to learn about networking, which is the backbone of all of what we learned so far. This is for the AWS Certified Solutions Architect certificate. Let's go ahead and dive right in. Okay, let's see. So, what is networking? So, it's how your resources communicate with each other and the internet. So, think of it like this, it's like how you connect with the internet. That's what networking is. Okay, so by your resources, usually they're talking about your EC2 or your S3, just basically all your services, right? How do people talk to your services to get your service, right? Okay, let's go ahead and do that. Well, let's see, why does this matter? Why do we need to network, right? So everything we learned so far, such as EC2, RDS, S3, Lambda, they all need a network to communicate each other, right? Without a network, how can users even talk to your app? How can servers even talk to their databases? And private systems cannot stay secure, right? So let's go ahead and dive right in. So here's a real world analogy. So think of AWS like a city. Okay, let's go ahead and draw that city out. This is a city. Okay, so a VPC is your private neighborhood. Okay, so there's subnets like streets, EC2 are like houses. Oh, damn. Okay, so we're living in this city. Okay. Okay. So a VPS is like our VPC. VPC, okay, first of all, let's go ahead and define it. So VPC is equal to virtual private cloud. Oh, shit, okay. Oh, shoot. Okay, I might have to restart this. Okay, so this is the city. And this is virtual, VPS is virtual private cloud. So let's just say this is our VPC. Right, subnets are like streets, so that's our subnet. EC2 are like our houses. Actually, let's see. This is like our street, and these are like our houses. Okay, so we got the VPC, we got the subnets, we got the city, EC2 are houses. Load balancers are like the front gate to get into those houses. So we all use the front gate. This is like a front gate to get into the street. Okay, and internet gateway, highway on the internet. Security groups are door locks. So your private network inside AWS, that's our VPC. Okay, so what is it? So it's a logically isolated network where you launch your instances such as EC2, RDS, etc. So every AWS architecture starts with the VPC. So this is AWS. We have a portion of it, which is our VPC. And our VPC hosts our servers. And inside those services, they have, see, this could be like an EC2, EC2, this could be like an S3. Basically, just our whole entire world. And what we control inside of VPC, we could have the address range, which is CIDR, subnets, routing, and security. So why do they even exist? Why do we even have a VPC? It's for isolation, for some control, and for security. So we could create a VPC, which is something like this. So our network can have many IP addresses. Okay. So subnets. So subnets divide your VPC. What is a subnet? So a subnet is a smaller network inside your VPC. So you could think of it like a VPC inside a VPC. right? So it kind of just separates things. So subnets is like a VPC in a VPC, right? And why do we use subnets? To separate resources based on security and accessibility. So there are two types of subnets, a public subnet and a private subnet. So public subnet is basically what everyone could see. So that could be used for load balancers, bastion hosts, and public facing servers. So an example for that would be like a EC2. Let's say someone wants to connect to it because this is a public, right? And a private subnet is no direct internet access. So it's used for databases and backend servers and internal services. So another one could be, this could be like an S3, which is a database or database storage. It could run something like an RDS. So we don't want people just to access all the information, so it's private. Because it could have some information like private information. And this is public information, just kind of like this is our service. So exam pattern, if we see database, we know it's a private subnet. If it's a public website, we know it's a public subnet. So the internet gateway allows your VPC to connect to the internet. Enables inbound and outbound internet traffic, which is attached to our IPC. So just connecting your, okay, let's see, let's write this out. So there's something called an internet gateway. So IGW stands for internet gateway. So it enables inbound and outbound traffic and attached to our VPC. So just having an IW. So, okay, so our VPC is really big. It hosts everything. It just basically circles everything. So VPC. So an IGWC, IGW is in here. So just having this is not enough, but it lets us talk to inbound and outbound. So we could say that this is the internet. It talks actually to the IGW. So we need a route table and a public subnet. Let's go ahead and figure out what those actually are. So what is a route table? It defines where our traffic goes. Route table. Okay, for example, we have destination. This is our internet gateway. Send all internet traffic out. So key ID is that routing is direction for traffic. Route table. Figures out where traffic goes. So we have actually an NAT gateway as well. Okay. Okay. Okay, so NAT gateway allows private subnet to talk to the internet. It should not be exposed to the internet, but still needs to update download packages. Okay. So gateway. So gateway is basically just a gate. So let's say this is our house. Let's say our house is an EC2. Then we'll have to access a gate. It could be either locked or unlocked. In this instance, it's going to be an NAT, which means that traffic only flows in one direction. So our EC2 could go ahead and access the internet, but the internet cannot access. See, let's just call this internet. The internet cannot access our EC2. It cannot. It's only one way, right? That's what it does. So private subnets should not be exposed to the internet. They're not, because it's only one-way communication. But it still needs updates, such as downloading packages. So that's why we go ahead and send information to the internet. And internet cannot send back directly to EC2. It would have to go through the gate and confirm. So Ani works outbound and lives in a public subnet used by a private subnet. So when we see that a private subnet needs internet access, we use a NAT gateway, which is NAT. They didn't really define what NAT stands for. I'll look it up. Network address translation. Yeah, network address translation. Okay, so we should have this glued into our brains. Let's go ahead and get it. So NAT stands for, N stands for network. A stands for access. T stands for translation. All right, just know that it's only outbound. So we'll have a private cloud, NAT. Here's a little architecture for it. It would have our private subcloud, which I'm gonna say private. Then you'll have something called like a NAT, which is connected part of a public. So it would talk to that. The NAT would say, hey, this is the internet, which I'm just gonna say it's the world. And world cannot go back to that. No, it can't. And that's what an NAT is. Ani works with outbound, lives in a public subnet. Yep, public subnet, and used by private subnet. Okay. So private subnet needs internet access. Always use the NAT gateway. Security groups and NACLS. So route tables. Let's see. Defines where traffic goes. So routing is direction for traffic. So let's go back. Internet gateway. Okay. So security groups and NACLS. Let's go ahead and figure this out. It's very important. Acts like a firewall at instance level. So it's a firewall. So NACLS. Damn, they didn't really define what it meant. Let's go ahead and look it up. Network access control list. Okay, let's go ahead and write that down. Network access control. What was L? Control list. Control list. So, okay, so it's attached to an EC2, allows rules only, no deny, stateful, allow rule only, I don't know what that means. So if inbound is allowed, response is automatically allowed. Okay. So we could say an example would be allow port 80. So whatever comes from port 80, we could allow. Whatever's coming from port 22, which is an HSH, allow that. So NACLs, network ACLs, network access control list, firewall at a subnet level. So think about NACL. NACL is like security. Chooses who has access. Okay, features allow and deny rules stateless. Stateless means that must allow inbound. Okay, let's go ahead and figure this out. So security, NACL is a subnet, and allow plus deny. Stateful, no. Stateful, yes, so type allow only. Instance. 90% of the time it'll be security groups, okay. Security groups, wait, hold on. Is that what this was? Security groups. NAT. Okay, right here, okay. Attached and easy allow rules, no deny. Subnet. So one's subnet and one's instance. Private access to AWS services. Okay. So private access to, so VPC endpoints is private access to AWS services. So EC2 is a private subnet, needs S3. EC2 in a private subnet needs S3. Traffic goes through the internet. Solution, VPC endpoint. Okay. So your EC2 could talk to this storage container, which is the database. So they established a private connection that no one else could see. Okay. That's a VPC endpoint. So there's no internet connection, right? A private access to AWS services. Okay. Types for exam. So there's S3 gateway endpoint. So S3 is for storage, and DynaDB is for database. These use gateway endpoint. Okay. Interface endpoint is for everything else, also known as private link. So if I see access S3 without internet, VPC endpoint. So you want to access S3 without internet. Well, this is an S3, right? Without internet. Wouldn't it be gateway endpoint? I think VPC endpoint has two types, right? These are the two types. VPC, which is this private virtual private cloud. So just private connections like that. Okay. Load balancing, quick reclap. Oh yeah, I remember this. Remember this? This is application load balancer. This is network. Um, yes, or security. I forgot what it stood for. Hey, gateway. Okay. So we have Route 53. So Route 53 is basically just a DNS, which stands for Domain Naming Service. Yeah, it converts stuff like, yeah, like google.com into an IP address. And then the IP address gets input into, I guess, like a network. It connects straight to that service. So routing types would be simple, one endpoint. Latency based is closest region. Route 53 is the DNS. Okay. I have to remember that. So route 53 is equal to DNS. Okay, let's see. Simple is one endpoint. Okay. Latency based, closest regions, right? That makes sense because latency means keeping it low. So like load. So for example, let's say I have something like I live in I live right here, right? This is house. This is my local machine. Right, there's two EC2s. This EC2 right here, and there's like an EC2 right here. All right, simple would be like, hey, okay, I have an EC2 right here, right, for my service. So I'd always talk to this one, no matter what, and it would talk back to me right here. And I talk back to it, and it talks back to me, right? No matter what I do, it'll always send to that one, right? Well, with latency based, it'll know to go to this one because if I was to send information to EC2, which is all the way over here, it'd be way further, right? So the time to come back would take longer, and that's what latency is. So that's why it goes to the closest region. Let's see other types of fallover. Primary to backup. Failover. Okay. I think this one means that if one fails. So basically this is my local machine. I talked to this one, but this one's broken. So a failover would be this one right here. Right? So because this one didn't work, I'm hitting this one. So that's what it means by failover, primary, or backup. So if you see route closest to region, we know that will be latency based, right? Oh, it'll be called latency routing. Okay. Next is global services. Let's go ahead and figure these out. So CloudFront is for caching and global delivery. Okay, and Global Accelerator improves network path and for static IPs.
Call from Kaiser Permanent.
Let's
Call
see,
from
another one would be
Kaiser
putting it all
Permanent.
together. Okay, so everything uses route 53. Okay, let's go ahead and get this out. So putting it all over together, so a user will go ahead and put in a request, right? And that request will go use route 53, right? Which will change that domain like Google, right? Into like an IP, let's say 1.1 point whatever the hell, right? Then it'll use an application load balancer, right? Which will tell you which application to go to. Let's say it uses this one. It chooses this one, and then from there, this is an EC2. And then from RDS, which is Relational Data System, which is their database. Remember, they have other databases such as Aurora and such as DynamoDB. And Aurora is really good. It's better than RDS in every way. DynamoDB is good for just quick lookups, but there's no relation. Very scalable though. And okay, let's go ahead and erase this. Inside our virtual private cloud, there's an application load balancer. Well, yeah, this one has to be public, so it could route the user into multiple EC2 instances, whichever them chooses. Let's see, EC2 is a private subnet, so EC2, and RDS is a private one, so let's say this is an RDS. Oh, actually, RDS is inside EC2, but yeah. So internet access has internet gateway, which is public, NAT, which is a private outbound. VPC endpoint is an S3. Okay, let's see. VPC endpoint is S3. So we could have, remember, many endpoints. VPC endpoint is just defining it. Wait, hold on. I thought VPC endpoints had different ones, like such as like, oh, well, I guess this endpoint would be a fixed one, right? Here, that would be one endpoint. Okay, looks like we're starting to talk about critical exam patterns. Let's go ahead and find them out. So high availability, yes, multiple AZ, multiple available zones is really good. Load balancer, make sure that they're not overloaded. So private subnet needs internet. So private, it needs internet, but remember NAT gateway, which stands for, I don't remember what it stands for, dang. But it's only one-way communication. So let's just say this is our S3. Actually, our EC2 would make more sense. EC2 would talk to the internet using a public subnet. Public. Right, and then that would talk to this. It could not talk back. It's only one way. Let's see. Private access to S3. VPC endpoint, yes. This is two-way communication. That would be VPC endpoints. These are both private. A secure database. So private subnet is equal plus a security group. VPC endpoint. Let me see. Let me try to look this up real quick. A private one-direction initiated connection from your VPC to an AWS service without breaking the internet. Stay inside AWS network. Avoid internet. No NAT. No IGW. Here, let me go try. How does it work? Does my EC2 use a VPC to talk to my S3. Is that how it works? Let me see. Okay, let's go ahead and try to read more on this. Let's see. The correct mental model: private tunnel out of your VPC to our service, not an open pipe. Okay. A private tunnel out of your VC. Types of VPC endpoints. Examine important. Gateway endpoint. Interface endpoint. Uses everything else. Without an endpoint, it would be EC2 to internet to S3. Now we could do EC2 to VPC to S3. EC2 in private subnet needs S3 without internet. Hold on, let's see. EC2 uses VPC to talk to S3. Your EC2 is already inside of VPC. EC2 is in a VPC, uses internet to S3. Okay. An EC2 instance sends traffic to S3. The VPC table, route table, directs the traffic to a VPC endpoint instead of using internet. Okay. Let's go ahead and, okay, let's go back to this. Okay. Security group was kind of just talking security on the application level, and one's on the network level. Okay, let's go ahead and keep on going. Let's see. NAT endpoints. NAT is internet access, but one way. The VPC is straight up private. Security groups NACLS, so the stateful, stateless. Security groups are stateful, NACL stateless. It's like HTTP. This is more like, I'm not sure, but something deeper. Okay, let's see. Public subnet. Understanding. Public subnets do not automatically needs IGW in a route table. Okay. Okay, let's go ahead and do a quick check-in. Okay, VPC is your private network inside AWS. Okay, so that's AWS right here. This is going to be our VPC. Subnets divided into public and private. So this is a subnet. So I'm going to say private, and this is public. A NAT gateway lets private resources access the internet securely. Yep, okay. Security groups control traffic at the instance level. VPC endpoints allow private connection across AWS services like S3. Yep. And Route 53 handles DNS. Load balancers distribute the traffic. Yep. Let's go ahead and move on to the quick checks. All right. Private EC2 needs internet access. What do we use? We can use, what is it called? A NAT, N-A-T, Network Access Gateway. Ooh. It's a private EC2. It'll go like this, and one-way traffic is public. And okay, web app accessible from internet. Which subnet? Ooh. Private EC2 needs internet access. Private EC2 needs S3 without internet. Without internet, we just went over this. it was what was the name? Private EC2 needs S3 without internet. It's like a VPC. Web app accessible public. Firewall at instance level. Security group. Which subnet? But we need a subnet with something else, right? Internet gateway. I want to say public. Yeah, alright, that's what I thought. Alright guys, that's the end of the video. Next video, we're going to learn about messaging, SQS, SNS, and event-driven systems. Thank you for watching.